Hello everyone, today we will be learning new chapter application of partial differentiation. It's an important chapter in all the universities, throughout all the universities you will find question on this chapter. There are various topics which are involved in it. So here is I put the list of the topics. So errors and approximations, maxima and minima, Lagrange method, Leibniz rule, Jacobian with implicit function, it's a part of the Jacobian only. Then Taylor's theorem we will be also learning, Taylor's theorem in one variable and Taylor's theorem in two variable as well. Along with this we will solve some question on each topic. So we can start with the first topics, which is errors and approximations. So before we start with the topics, like as it name suggests, like errors and approximations, like wherever during the measurements we come across some human errors or any mechanical or machine errors, that time it gets useful to find the approximations during the calculation. So we can use that in those cases. So here I have taken one example. Let's say how we use it. Let's say here z is the function of x and y and this x and y are variables. So if there is any change in small change in happens in x value and y value as well, so since the variable value has been changing, the z value is going to get definitely it's going to get changed. So if you want to find the corresponding change in the value of z because of change in the value of x and y. So how to find it? For that we use this formula which is written here. Before I go with the formula, this is called delta x and this is called delta y. That shows, that indicates, or that we use it to represent very small change in x value or y value. So that's nothing but the sign is a delta. So those represent the small changes in the value of x and y. So we have done, since the variable are changing slightly, so definitely the function which is z, it's going to get changed. So corresponding change in the value of z that I have, we can show it by using delta z, which is shown here. So how we find the corresponding change which happened in z is we have to take differentiation of the variable which are involved in here. In this case x and y are there. So partial differentiation we will be taking with respect to x. With that we have multiplied with this value which is a change in the value of x, which we did it by delta x, and similarly we will be differentiating the whichever variables are there. Since this function is function of x and y, we are differentiating partially with those variables. So here del f by del y, and again we have to multiply it the whatever change we are doing in y value, which is delta y here. So this is the formula how we can measure, how we can find the error which is going to happen because of the change in the values of the variable which are related to that function. Similarly, if there are, this is the case for two variables, z is a function of two variables, but if in case if any given function is of three variables, it includes three variables. For example, I have taken here u is a function of x, y and z. So these are the three variables. So if I change, if I do small changes in the value of x, if I do small changes in the value of x, y and z, so the corresponding value, like u's value, is definitely going to change. So how we can find it? Same thing here. It doesn't matter it's a two variable or it's a three variables are there. The using the formula is going to be remaining same. Since three variables are here there, we have differentiated this given function u three times with respect to different variable, like with respect to x, with respect to y and with respect to z. Partially we did differentiation, and the only thing which you have to remember is we have to multiply this, whatever changes we are doing, that we have to multiply with it. So this is how we are going to use the formula to find the errors, errors or approximation when there are two variable or it's a three variable function. Let's take a small break over here. Meantime, you can revise the concept. In the next video, we will be discussing this more in detail.